Everyone get on the webinar before we start. We do have a little bit of housekeeping to take care of. First of all, I'm Seth. I'm on the marketing team here at Pluralsight. The first thing that we wanted to call out before we pass it off to Dan is that, as you may have seen on social media this morning, Pluralsight has opened up its entire library of 7,000 plus courses, learning paths, and skill assessments for free for the entire month of April. We did this last year, and we're doing this again this year to allow people to get in and skill up. So if you're interested in taking advantage of this free offer during April, if you just go to pluralsight.com, you'll see a large banner on the top of the homepage, and you can visit that to create your free account. And there is no credit card or payment info required. Second, as part of free April, we will be hosting also our third annual Tech Skills Day live stream on April 22nd. We'll have a lot of great technology speakers kind of discussing their technology skills journey. So if you visit techskillsday.com, you can get more information on how to register for that free event as well. And then finally, because we do get a lot of questions about this webinar will be recorded. If you're watching via Zoom, an on-demand version will be sent to the email that you registered with within 1 to 2 days after this event is over. And then it'll also be available. You can also find it on our YouTube channel and pluralsight.com shortly after the event as well. If you're watching straight from Twitter, Facebook, or YouTube, an on-demand version will be available immediately after the event. And I also want to call out that we will be having a short Q&A session towards the end of the event once Dan is done with his presentation portion. We are expecting quite a few questions, so as soon as you have a question, drop it in that Q&A box at the bottom of the screen, and we will get to them we'll try to get to them in order. All right, all you, Dan.
All right, well, thanks, Seth, and it's great to be here, everyone. Thanks for joining. So over the next around 45 minutes or so, I'm going to introduce you to Kubernetes, but from a developer standpoint, because you hear Kubernetes, if you know anything about it, typically you think, oh, well, an IT admin is going to manage that, which is usually the case in production, or a DevOps person or something like that. So why, as a developer, would you even care? And we're going to talk about that and then introduce Kubernetes, some of the fundamentals to you. So as Seth mentioned, my name is Dan Wahlin, and I am a cloud advocate at Microsoft. Also do a lot of courses for Pluralsight. And in fact, one of them, we have a whole learning path on Kubernetes for developers. So I'll provide some info at the end about that. On Twitter, though, if you want, I pretty much just do tech tweets. I'm not one of those, hey, I'm going to the store type tweeter people. But feel free to look me up there if you're interested, and then that's where I blog at. So with that, let's jump right in. So why Kubernetes? There's a lot of good use cases for it, and there's a lot of bad use cases for it, a lot of abuses, I guess you could say, where people buy into the hype, they jump on the bandwagon, and then realize, oh, maybe we didn't need this. So we're going to talk a little bit about that. But Kubernetes itself is all about containers. So if you've done anything with Docker or Rocket or any of the container OCI type options, Open Container Initiative options out there, you'll know that we can run different containers, but you're going to want a load balancer. And what happens when one of these containers goes down, or in this case, two? How do you recover from that? Well, if you just use containers on their own, you don't really recover from that. You would have to have a process that you have in place. You otherwise would need something like Kubernetes to help with this. Now, if you only have, one container and you have a monitoring system, it's probably good enough that you could just have some automation process that restarts the container if it fails. But for a lot of us, we have apps that have APIs, we have front-end code, we have back-end code, we have, message queues, who knows? And you might have a lot of containers running. That's where Kubernetes can really help out. So let's say, for example, we had Nginx on the front end hosting a React or Angular or something like that web app. That calls into multiple APIs. The APIs call into databases and caching servers and all that type of stuff. If all those were containerized, how are you going to manage that? And that's really the question that we're going to address here with Kubernetes. So wouldn't it be nice if you could just package up your app, provide something called a manifest, basically a file or 2 or 3, and then let some other product, some other thing, we'll just call it for now, actually take care of not letting you worry about the containers, let it worry about the containers. Eliminate single points of failure. So you could have a load balancer, for example, and if one of those does go down, no big deal. It'll just route to the others, and you can even bring up a container if it goes down. Have a way to scale. You may work for a company where, let's just pretend right now it's really slow, but during maybe the summer or during the holidays or something like that, it really picks up and you need to horizontally scale. Literally add more servers or VMs, if you will, into the mix. You can do that with Kubernetes. Easily update containers without bringing down your whole app. How many of you have been on these, let's start at midnight and hope we're going to be done by 2 a.m. And then around 4 a.m., something went wrong at 2 a.m. and you're still there at 4 a.m. Hopefully nobody goes through that, but back in the day, I definitely had many of those nights where you're doing a massive deployment. So what we really need too is when it comes to a lot of containers, there's a lot of networking that goes on and communication between these containers, and we need to be able to deal with that as well. So what if you could define the containers we want to run and then just kind of hand that off? And it'd be like me, since Seth introduced me here, it'd be like me saying, hey, Seth, here you go, take over. And he magically makes all those containers work. Well, welcome to Kubernetes. That's really what it's designed for. Now, the question of the day, though, since this is geared more towards developers, is why would you care? Because odds are you're going to be writing the code. Now, some of you maybe create container images, maybe. Some of you maybe even start and stop the containers. I doubt it, but if you're also production support, that may be part of your role. But most of us, we're just coding every day. So you want to develop against real services, though, and this is where knowing Kubernetes is good. If I were just to bring up some containers, like I showed earlier with Nginx, then we have some APIs. Well, if I only had one for the API, but in production, it's actually, let's just say 5 for scalability. How stateless is your app, and does it work properly when there's 5? And how do you test that? It's a little bit harder when you're local. So that's one thing, is we might want to actually simulate production at least as much as we can, either locally or on maybe a dev type setup. The other thing is you can do development and you can handle our staging production deployments and practice that. So they have, we won't cover them today, but you can do blue-green deployments or canary deployments, or just rolling updates, they're called. And basically this is the process of, I want to release a new container, but I don't want my app to go down, right? I don't want people to know that we're updating and have some downtime. Now I'd offer these days with all the DevOps and CI/CD systems we have, it's gotten a lot better than it used to be. But with Kubernetes, that's something that's built in to make this possible. Maybe you're doing end-to-end testing. Maybe you're doing performance testing. This would be another good reason that you might want to use it. Or maybe you just love working containers and you want to learn it because you like it, and that's fine too. So the bottom line is, if your company is going to be using Kubernetes, I personally think as a developer, it's at least good to know the fundamentals, because at some point, some issue comes up. We know that's just welcome to our world of technology. And if you're able to help out your IT admin or DevOps, it's a bonus. Definitely adds value to what you do in your job. So let's go through kind of the big picture here. This is the official definition. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. And if you're new to this, you're probably going blah, 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 right? So if you like sports, you could think of it this way. You have a container here and container here. Or if you're into, non-American football, the real football, I guess you could say, in most of the world, these would all be, each player is like a container, and you can almost think of Kubernetes as the coach of the container team. Or if you're like Dan, I don't do sports, and I don't know, maybe you like orchestra, let's say, for example. Well, you could have the conductor, of course, and then you have the different members of the orchestra playing. That would be your containers. And so you could say Kubernetes is the conductor of a container orchestra. So however you want to think of it, it's all about managing the containers and kind of reining them in, allowing you to deploy them, scale them, handle failures, all those types of fun things can be done. All right, so from a really high level, what Kubernetes is then is a container and cluster management system. So it does deal with clusters because, as you're going to see in a moment, you have multiple servers. It is an open source project that came out of Google. It's been around for a long time now, so it's not new. Every major cloud platform supports it. I work obviously with Azure the most, so you can do Azure Kubernetes Service, AKS, and it provides a really easy way to get started with these type of things. But Google supports it, of course, in their cloud, and Amazon, and even others that are out there. Now, what's really nice is while you can use command line tools to get your containers going, and we're going to do some of this coming up shortly, there's also a declarative way to say, all right, we have no containers out there, but I need, let's just pretend 10 containers out there in this way. Well, you can define something called YAML files. And we're going to look at those in just a little bit. And I'll show you how to get started with them. But basically, it's just a text file. And so if you've ever done Docker files, Docker build files, those are just text files with instructions to build your Docker images. With Kubernetes, we have something similar, but it's called YAML. So some of the key features here. Number one, load balancing. Orchestration of storage. If you need to store data outside of the containers, you can do that with Kubernetes. You can automate rolling out new deployments, or you could even roll back to a previous version. Maybe you went to version 1.1, something went wrong. You could actually just roll it back to 1.0 if you wanted. That's possible. A lot of companies roll forward, but you can go back. You can even orchestrate batch processes using Kubernetes. So if you have like a nightly run of a report or something that has to run, you could schedule that in Kubernetes. And that allows you to manage these different workloads. One of my favorite features, though, is self-healing. I mentioned earlier, what do you do if a container goes down? Well, you probably want to bring it back up, but you don't want to have to be responsible. Your IT admin or DevOps people don't want to be responsible for that. So with Kubernetes, it can self-heal. And then if it brings it up and it crashes and it brings it up and it crashes, then it can pull it out. It's smart enough not to keep trying if it just constantly crashes. If you have sensitive data, connection strings, certificates, all that type of stuff, they have a way to store that, as well as configuration data that you want to store. And then I mentioned earlier, you can even scale out, and we'll talk about that right here. So here's how it works. So you have this thing called a master node. And the master node is basically the thing that drives the whole show. All right. It's the boss, if you will. It's just basically at a minimum one, but typically this will be multiple VMs. And the master is then going to communicate with your container servers, you could say, your virtual machines typically these days. So a node is, think of it as a server, but I'll just call it a virtual machine. All right. And on those nodes, we can run one or more pods. Pods you're going to see run containers. All right. So the master is kind of the boss that says, all right, run this, run this, run this. The servers here, the VMs, listen to the boss. They then run the node pods, and then the pods have these containers. So let me break it down a little bit further here for you. So pods are really the unit that runs your containers. Now, why do we need pods to run containers? When we get to networking, that'll be much more clear, which we're going to cover in just a little bit as well. But think of a pod as a way to run one or more containers. Now, I'm going to offer that a lot of times you just run one container per pod. However, there are scenarios such as you have a container running and you have something that pulls the logs out of that container. They have what's called sidecar type containers. Well, in that case, because that log container needs the other container, you might run two containers in one pod. For all the stuff I do and have done over the years, I typically run one container per pod, but again, it depends on what your needs are. Now, that means that normally your web app would be in one pod, that'd be one container. Your API would be in another pod, that'd be another container. If you containerize your databases, that'd be another container and another pod. Now, the way we deploy these pods, which ultimately run the containers, is through something called deployments. And deployments are responsible for saying, how many do we want of these? You have something called a replica set. And if this one on the left here, let's say that's the web app, and that gets tons of traffic, then you might deploy more of those. So you could say in the replica set, I want 3 web apps, I want 2 APIs, and I want 1 database pod, if that's what you were doing. Well, the deployment ensures that you have that number, 3, 2, 1 in this case. If one of your containers inside of a pod or the pod itself crashes, then the deployment would go, whoa, we wanted 3, we now have 2, we've obviously lost 1. So it would recreate that one and be back to the state that you desired. Now, you also need a network between these, because obviously if this is a web app right here, it would need to talk to the API and talk to the database and that type of thing. So we have something called services that we're also going to talk about here. And they're very important for the networking aspect and communication between our pods. And then I mentioned earlier, you can also store data outside of containers. That's storage. You have something called config maps. Think of that as key value pairs that you might want to make available to all the pods. That could be everything from just app version, for example, connection string if it doesn't have a password in it. Anything that's more sensitive is called a secret, and you can store that as well in Kubernetes. So that's kind of the really big picture. And this is all going on behind the scenes with Kubernetes. And we as developers, at least locally, can work with this. And I'll be showing you that as a demo here. So there's many ways you can get Kubernetes going. I'm going to be using Docker Desktop, which is the one on the right here. But Kubernetes in Docker, that is an option. Minikube is an option. If you're on Mac or Windows, by far, I think the easiest option is Docker Desktop, which I highly recommend. If you're already using Docker, you probably already have that. Or you could even do kubeadmin, it's called kubeadm. Now that's the full-blown Kubernetes, but you could even do that if you had Linux, for example. So I'm going to be using Docker Desktop. And with that, let me just show you really quickly. When you go to docker.com, install Docker Desktop, you have an option to enable Kubernetes, which is super cool. They've had this for quite a while now, actually. And if I go into the preferences, so I'm on Mac, but in Windows, it would be down in the tray. And you could go to your tray, and then you'll see this little whale icon. If I go to preferences here, and let me let this bring it up, drag it over here, you'll notice this Kubernetes. And then I can literally just check this checkbox here and then apply, and it'll restart. And then you'll notice down here in the bottom, I have Docker running and I have Kubernetes running. Now, I'm going to show you some commands here in just a moment, but the big one is called kubectl. And so you can kind of check, are things really running, by just typing that, hit enter. And you'll notice that I get all these different kind of help commands available here. Let me just make that bigger for now. So this kubectl, you're going to see in a moment, is how we're going to interact with the Kubernetes master. But before we do that, I want to show you a little more details here on how that all works, so you understand what's going on behind the scenes. All right, so the boss, if you will, communicates with the nodes I told you about. But let's break this down just a little further. So if you have multiple things it needs to track, then we probably need some type of a database, right? And they use something called etcd. That is our store of information for our cluster. Now, this is something you don't have to worry about. Especially if you go with the cloud providers, you won't even have to set this up. You just run a couple commands, and it's kind of like, magic wand waves, and poof, I have my Kubernetes cluster. If you're setting up locally, more than likely, you're going to have some type of a Kubernetes admin who would set it up. But of course, if we just want to run it locally, we could use Minikube, Docker Desktop to do that. and it would have all this for us just with checking that checkbox I showed you. So the store is going to be responsible for kind of tracking all the things and stuff we have in the cluster. Then you have a controller manager behind the scenes. This controls what's going on and can schedule things. There's also a scheduler that will say, if you say I need 3 pods, it will schedule those. The controller manager handles scheduling. The scheduler then pushes those updates out to the nodes over the network, and then they magically update to, let's say, from 0 pods to 3 pods per node. And then finally, we have something called an API server. And this is really important for us as devs to know about. This is the one thing, because that kubectl command I just ran, or you'll hear kubectl, there's a lot of ways to pronounce it, but that's something we're going to interact with. So let me show you that. This is the kubectl then. So what I'm going to do in a moment is I'm going to get a pod and a container going just really quickly for you. Show you a really quick demo that you could do as well, very fast. And what that's going to do is send a command over to the API server. That will then ultimately schedule that command through the controller manager scheduler combo, and then push whatever it was we told kubectl to do down to the nodes. So if we told it we wanted a pod with a single container in the pod, then it would start up a pod like you see here at the bottom on all of our nodes, in this case, our VMs, if you will. If we then said, oh, I want 2 pods, or I want a completely different pod that we don't have currently, then you could use kubectl to do that. Now, I'm going to show you a different way where we can define it in files, and then with one kubectl command, we could deploy an entire cluster worth of web server, APIs, databases, caching servers, all that fun stuff. But we'll get to that in a little bit as well. So let's talk a little bit more about nodes and pods and services, and then I'm going to spend the rest of the time kind of showing you some demos here. But we need to set the foundation first, especially those of you that are new to this, because if you don't really understand what's going on, it's kind of a little intimidating. So nodes and pods, we've already talked about that the boss communicates down to the node, and we have this thing called a pod again. And the pod is, I think of it like the spacesuit around the astronaut. The astronaut is the container, the spacesuit is the pod. Or you can think of like the lunar capsule. The astronauts inside of that, they would be like the containers, but they're saved from the coldness of outer space by the pod, if you will. That's exactly what's going on right here. So the way it works is you can run many pods on a given node. And again, a node is just a VM, a server, that would be running whatever your target operating system is. So when we do this as a developer, we're only going to have a single node in Docker Desktop. That's all it gives you, is just one. So you won't be able to simulate, having a bunch of nodes and communicating between those nodes with just Docker Desktop. Now you could with Kubernetes and Docker, you could with kubeadm. This is the full Kubernetes. And maybe at work, you even have a development cluster. I would suspect you would. I would hope you would. Or a test cluster or something like that. But just kind of know that on Docker Desktop, you get one node and one node only, but you can run many pods on that one node with Docker Desktop. Now, each node needs to be able to talk to the boss, right? The master node. We have the kubelet, and the kubelet is responsible for that communication. All right, this gets installed on the nodes when either Docker Desktop, Kubernetes is enabled, or when you install Kubernetes somewhere. Now, we also have a container runtime. Now, this could be Docker. It could be something called Rocket. It has to be what's called an OCI, Open Container Initiative, compliant runtime. So Kubernetes can actually run any type of container as long as it's OCI compliant, which is awesome because that means you're not locked in to just Docker or Rocket or some of the others that are out there. And then you have a kube proxy. And think of this as kind of your networking for your node. All right, so you have these virtual subnets and all this fun networking stuff that we're not going to get into today, but it'll handle all that for you. All right, so a pod then, to sum up, is really just an environment for containers, like an environment for astronauts, if you think of a spacesuit or a lunar orbiter type thing. It is the smallest object in Kubernetes. All right. Container doesn't count. That's even smaller, but container is kind of what Kubernetes is doing. It's not part of Kubernetes. It just runs containers. And then pods are going to have an IP address. They're going to have their own dedicated memory. They can have their own dedicated storage, or what we call volumes. And this is shared across any container. So this pod over here to the right, there's one container, but if we added 2 containers, both containers then in that pod would share the same IP, the same memory, the same storage, all that, whereas another pod would get a completely separate IP, memory, storage, all that fun stuff. Now we can scale out pods. We can add more to a node, or we can even do what's called horizontal scaling, and that's where we want to add pods across multiple VMs. We want to add more VMs. Now, an important thing to know about pods is they can live and die. So you cannot count on a pod always being there. And that's luckily handled for us. That might sound scary at first, but it's not. So if we put all this together, then really most of this you don't have to know as a developer, but it's good to know the basics, that there's this boss, if you will, and it has a store and it has an API server we can communicate with. It schedules all the changes and it controls what's going on. That talks to all the nodes. The nodes have networking. That's the kube proxy. There's a kubelet, and then that communicates with the boss. And then we have a container runtime, of course, so that the pods can run our containers. And that's really what's going on here. Now, with that, the one important piece, well, 2 important pieces here, actually, we haven't talked about to wrap this up, and then I'll show you some demos, is services and deployments. Now, if I go back real quick to these nodes, how would a web browser call that first node on the left? We'd probably have to have an IP address and maybe know the port, stuff like that, right? Well, networking is a really big part of Kubernetes. So we're going to briefly talk about how it works. So I mentioned earlier that pods live and die, so you can't rely on them having the same IP address every time. Every pod gets an IP. That means you can get to that container that you see using that IP and then whatever port it's listening on. So in this case, 10.0.0.43 or 4.5. But what if that container on the left dies? Like it just goes away and a new one comes up. Well, you're not guaranteed that the same IP address is going to be there. So now if you had another pod talking to this one on the left and this pod dies, well, that would break your communication, right? That's kind of like you giving me your cell phone number, but your cell phone number changed. And now I keep trying to call you and it just, this number is no longer available is what I keep hearing. So fortunately, we can't rely on pods, no, because they live and die, but services will handle this for us. And the way this works is, this is a pretty good visual here, is if we have a pod with an IP, we can associate each pod with a service that has an IP, and that IP does not change unless you or an admin deletes the service. So what we're going to do is we're going to set up a service that can communicate with our pods. That IP 10.0.0.1 isn't going to change. Okay, it's going to stick around. And if this pod on top over here dies and a new one comes up, let's say 10.0.0.40 is what comes up, the service will automatically manage that. So now any other apps that are running in pods and containers in your Kubernetes cluster, all they have to know about is the service. It will automatically handle any changes behind the scenes to the pod. So it's kind of a facade, if you will. Now, the way we associate pods with services is through something called a label. And we're not going to have time to get into all that right now, but just know that there's a way very easily to associate these. And I'll show you some of the YAML files coming up in just a little bit. Now, there's different types of IP addresses and services. Normally, a service is what's called a cluster IP service, meaning that only stuff in the cluster can talk to it. Nobody outside of the cluster can hit it. Obviously, if you're doing a web app, that doesn't help much because you have a browser that needs to call it. And that's where you can set up a couple things. They have a load balancer option. There's something called a node port. And while I don't have time to go into all that in this short webinar, Just know that there are many different ways we can talk to our cluster. Load balancer is pretty common, and there's even some others, some kind of doorway options, ingress they're called. Now, the last little piece here before I jump in, and then you'll know enough that we can do the demos here, is called a deployment. So we know that we have pods, and we know those run on nodes. We know they get scheduled through the boss. Well, deployments are how we schedule that. So either we as developers or an automated process, if it's for production, can push out a new deployment. That deployment controls then everything we have. It could set up a deployment for a service. It could be a deployment for a pod. It could be a deployment for other things, such as batch processes. Lots of things we could do. What's so great about deployments is they basically allow you to say, hey, I have 2 things, but now I want 4 things. And through the deployment, you can say, okay, go from 2 to 4. And then without bringing down your app, it will make that happen behind the scenes. And a deployment sets up so that if you wanted 4 and 2 of them die because something crashes, it'll bring those back up. And so it kind of self-heals, if you will, which is really nice. All right, so with that, I'll give you a link at the end to the slide deck here, because there's actually a bunch in here I'm not going to cover. We're going to wrap up with some demos here. So let me run on back to the command line. And we know based on what I showed you earlier that I already have Kubernetes running. Okay, so that means I have kind of the master setup and I have the node set up. Just a single node, but it works. And that means I can come in and type kubectl and talk to the master's API. Okay, that boss node, if you will. So if I just hit that, you'll see tons of commands. Don't worry about that. Don't let it intimidate you at all. Now, the first thing I'm going to show you is we can do kubectl get. And if that's all I did, it's just going to give us some, hey, you need to be more explicit. So what I can do is kubectl get pods as an example. Let's go ahead and do that. And it should have no pods. So notice no resources found. Okay, let's do kubectl get services. Ah, look at that. I have 1. Now, this is kind of the default service that when you set up Docker Desktop, you will get. Now, notice it's a cluster IP. Okay, that means I can't actually call this at all. It's internal to the cluster, but we're going to do some things here in a moment. Or if I just want to see everything, I can do get all. And that's all I have is the service. So there's no deployments. There's only 1 service. There's no pods. There's this other thing called replica sets. There's none of those. So right now I'm pretty limited on what I have. Now, what's great about kubectl, if I do get, if I just hit enter here, first off, it's going to tell you can add -h, you'll notice right here for help. I think we're all pretty used to this. Although if you're like me, you'll do this. You'll be like, is it this? Is it this? Is it this? You know, anyway, they kind of tell you. And then you'll notice there's a ton of command line switches, a ton of examples you can get, lots of info you can get here. So any of these commands I'm going to run here, just add -h and you can get more info. And then if you just want to see the commands, you can just hit enter, kubectl enter. Now, the first thing I'm going to do is I want to run a pod with a single container. So I just have a little bit to save on typing here. I'm going to paste in. And let me kind of walk you through this. So we're going to say, all right, kubectl, I want to run a pod called hello nginx. So we're going to run an nginx container. The container image I'm going to use, and Docker Desktop uses Docker Hub by default to get the containers or the images, is nginx Alpine. I already have that on my system, so it should be pretty quick. And then the port I want is 8080. Now, internally, nginx Alpine uses 80, but I want to say that this pod is going to expose 8080. Now, let's see what happens when I hit enter here. All right, it says pod hello nginx created. So now let's do our kubectl get pods. All right, and we have 1. Now, you would probably at this point do what I did the first time and go, cool, I can hit like, you know, localhost 8080 or something, and you do it and ooh, doesn't work. And then you're like really bummed because you're going, this should have worked. And no, it shouldn't have. Why? Let's go back to services here. See how we just have that cluster IP service? And notice it doesn't know anything about port 8080. All right, right now we don't have a service that's exposing this. Now there's a couple ways we could do this. I'm going to come in and grab kind of a longer command that I'll walk you through. We could do one command called a port forward. That would work. I'm not going to do that though, because I want to show you a service. So I'm going to do this command. I would like to expose a service for the pod called Hello Nginx. Now, look at our name right up here. Hello Nginx. Okay. The type of service, though, is not a cluster IP. I want to be able to hit this externally. So I'm going to set up what's called a load balancer service. That will, with Docker Desktop anyway, make it where you can just use localhost. The port I want to expose is 8080, but the container port, the target of the container that's in this pod is 80, because that's what Nginx runs on. All right, so one more time, we're going to expose a service for a pod called Hello Nginx. We know we already have that pod because we did our run command up here. It's going to be a load balancer service and expose port 8080, but internally it'll forward that to port 80 in the container. So let's go ahead and try that. All right, so it says it's been exposed. Let me clear this. We'll do kubectl get all. All right, now look at that. We have our pod. That is running our container. And notice we now have a load balancer. Now notice it does have a cluster IP, but look at the external IP, localhost. Now that's because of Docker Desktop. Docker Desktop makes it easy so that we as developers can just call into this through what we're used to, localhost. Look at the port, 8080. Now in reality, this is the port of the node that's running, the VM that's running, but we don't have to worry about that. So let's go back now. Let's go back to localhost 8080. Let's hit enter and voila, we can now hit Nginx. We're doing pretty good there, all right? Not too bad. Now that's not super impressive. That's just one. I have a little bit more I'm going to show you, and you can play with it later if you'd like. Now, what do I do when I'm done? Because I'm probably never going to use this ever again, right? It was just for a quick and dirty demo. Well, we need to delete things. All right, so because I've done everything imperatively, and by imperatively, I mean through the command line, which is not optimal. I'm going to show you a better way coming up. We're going to have to do it imperatively. We're going to have to do kubectl delete. And then notice we have this Hello Nginx. So I could either copy and paste that, or you can just do like pod space. That'll work too. Hello-Nginx. And give it a second. Should be pretty quick. And then it's now going to delete this pod off the node. So remember that scheduler and the controller manager and all that fun stuff? Well, that just scheduled that to be deleted, which I don't know why it's taking so long, because it's a pretty quick process normally, but that's okay. Okay, there we go. It's done. So now let's do get all. And notice I no longer have a pod now. So my container's gone, my pod's gone. I kind of killed the astronaut, if you will. Now we still have the service. Notice the load balancer here, and look at the name. Now in the interest of time, I'm just going to copy that one. We're going to do a delete, and we're going to delete that service now. Gone. Let's go back to get all, and now we're back where we started. Okay, so if I go back to the browser just to prove it, notice it doesn't work anymore. Okay, so that's what we would expect. Now that's nice, but I mean, come on, it's like, Dan, that's a static, website. It's a single pod. Come on, like that's not even a good demo. Well, it's good to work with kubectl, but I'll agree that's pretty weak. So I'm going to have a link here at the end. I'll give you this little project. This is a Angular Node.js type of app. It's still pretty simple. But you'll notice up here, I have this folder called K8s. That's shortcut for Kubernetes. The 8 is the number of characters in that, Kubernetes. And notice I have an Nginx deployment, Nginx service, node deployment, node service. Okay, so let's crack one of these open. Let's go to the Nginx deployment. This is going to run the Angular application, the front end, or it could be React or whatever. And you're going to notice this special kind of file here. Let me make this a little bigger for you. Now, I do not expect you to memorize this. I just want to show you, this is called YAML. What I want to show you is this replicas 1. I'm saying I want 1 pod. What's in that pod? Come down to containers. Looks like I have an image called Nginx Angular Jumpstart. Now, there's instructions in the README for this project. You'll have to build your images to get this working. In fact, let me just show you that really quick. So if we go to the README, jump down to the running in Kubernetes, and I'll give you the link again to this repo on GitHub if you want to run this. And then you just run through these steps right here. This does assume you have Docker Desktop or at least Docker Compose installed. So coming on back here, basically what we're saying is we want 1 Nginx pod with a container that's going to be on port 80 or port 443 for SSL, if we had SSL going. And I have a custom image I'm going to run. Now, likewise, if we go to the node deployment, let's skip down because there's a little bit more to this, but notice it also is a deployment. Okay, so I want a pod. I just want 1, but I could say 2, 3, 4, 5, whatever you want. And then if we come on down, I'll skip that. Let's go to here. I have a custom image, and that's going to be the container that's going to run. It listens on port 8080, in this case, internally. Okay, now there's a little bit more in here. There's things called config maps and all that fun, but sadly with only 40 minutes or 45 minutes, I don't have time to cover everything. But let me show you, now that you've seen those, I now want to run those 2 pods, and I want to set up 2 services. Okay, now the Nginx service is a load balancer. It's going to do the exact same thing you saw me do earlier with the expose command, but this is now going to run basically a service that knows about the pod for Nginx and then make it so that I can call it externally. So now I want to run the whole app. Now you'll notice some commands here. I've already run this build because that takes a little bit. Now, if I want to run all those YAML files here, like all at once, it's kind of one batch, I can do a little trick. kubectl apply -f. Now -f stands for either file or folder. So we can come on in and I'm going to say, let's go to that K8S folder and I want to run all those things. So that should do 4 things. Should do 2 pods, 2 services, and notice it says they're all created. Okay, so to wrap this part up, let's do kubectl get all. And there we go. There's our 2 pods. So we have our Nginx and our node pods. We have our load balancers. So we can call the API through localhost 80 or localhost 8080 for the API. We're going to call localhost 80, which will call the app. And then we have these things called deployments and replica sets. Notice I said I wanted 1 replica set. My desired was 1, my current is 1, and 1 is ready. So we're good. On my node 1, I desired 1, I currently have 1, and 1 is ready. Now I could actually go in and change this to, hey, I want 2, and rerun that command to apply it. And I would now have 2 pods for Nginx if I wanted, or 3, or 10, or whatever you want. It's very, very cool. Now, you can see for those that are brand new to this, there's a lot to this. So first off, for those that are brand new, don't let all these commands and files be intimidating. I'll admit, I was really intimidated at first when I learned this, years ago. Now it just feels, I don't know, normal. And it's like playing an instrument. You just got to practice. So don't let any of this intimidate you at all. But let's go see if it works first, and then we'll wrap up here. All right, so it works. So this is the app. It basically allows you to get customers from a node service. You can log in. It's all kind of fake login, but we'll log in. I could edit, change TED to TED2, update it. Pretty normal app here. Go back to the home page. There's TED. View TED's orders. Google Maps, although I didn't supply a credit card, so it'll just give you kind of a temporary map. But you get the idea. So to wrap up then, let me first delete this, and then I'll show you where you can get info about this. So the last command is we want to run this delete. I want to clean up now all those 4 resources, 2 deployments, 2 services. So I'll go ahead and delete, and there we go. Now, if I'm fast enough here, yeah, notice this is terminating. It's still not deleted. Our services are gone. Our Nginx, it's super fast to clean up. Node takes a little longer, or if you're doing like Java or .NET or something like that, they'll take a little longer. But if we let this run a little bit, it might be gone now. Nope, still terminating, but give it a few more seconds, it'll be gone. And that's it. So you could see that running this as a developer, yeah, there's some things you need to know up front. But I guess the good news is, as a developer, first off, once you know the basics, you can jump right in and get started pretty quickly. So where do you get this? Well, first off, the presentation here, and I've actually added a bunch more slides. I knew I only had about 45 minutes here, max. So if you want just the slides, you can go to this link here. So just, I don't know if you have your phone, take a picture or something. I can probably, I don't think we have a chat. So I don't think I can do that. Now, this is the project I just showed you.
Dan, just a second.
Dan Wahlin. Yeah.
So we actually, we have the ability to send the slides to people after the webinar just through the email they registered with.
Oh, perfect. Okay.
So we can do that for everyone wondering.
Cool. That, or just take a picture, you know. So anyway, to wrap up, the project I just showed you here, this Angular Jumpstart, that is the project. Go to the README. As long as you have Docker Desktop going, you could get it going as the README shows, but you could use Kind, Minikube. There would just be a few tweaks you'd have to do. If you want a more robust one, you can go to this Code with Dan Docker Services, and it's much more robust example with Kubernetes. And then this is a link to the course code from the Kubernetes core concept, for Kubernetes for developers core concepts. For those that are already on Pluralsight, and it's, guess what? As Seth said, it's free this month. So everybody can go watch this for free if you'd like. The Kubernetes for developers learning path, we have a bunch of courses in there. The core concepts is going to give you way more details than I have time to go into in 45 minutes. So you can go check that out. So with that, I hope everybody gets the idea of what the master is and the nodes, pods, and containers. We've talked about deployments. Say, hey, I want 1 or 2 of these, and it just makes it happen. And that gets your containers running in the pods. Services handle your networking, right? They allow us to get to our pods. And then deployments are how we get our stuff out there, our services, our pods, and other things as well. You can either deploy through the command line, or you can do it declaratively through YAML. And then finally here, you saw the kubectl or kubectl, I've heard it. I don't know which one's right. I say kubectl. And you can use that to interact with the API server. And that's everything you saw me do. That was actually making RESTful calls, since we're all developers here. In reality, it's just making a RESTful service type call. So with that, thank you so much. We'll jump to the Q&A here, Seth. I'm gonna go back to this slide and just leave it up though, as we're doing Q&A. And then,
all right, sounds good.
Yeah. So Seth, I'll turn it back over to you.
Yeah, we have quite a few. I'll let you make a call. I think some of these might be specific to what you were talking about at the time, but I'll let you make the call.
Okay.
So first question I want to start off with is kind of a fun one. Someone said your webcam looks great, and they're curious what
oh, thank you. Yeah, fun. So you don't even want to get me started on this, folks, because I'm a huge audio video junkie. I used to do a lot of music back in college days. So I have a Nikon D7500, but I just got something called an ATEM Mini Pro, ATEM Mini Pro. So anyway, go search ATEM Mini Pro. It's phenomenal. It allows you to, I can even switch cameras, but I'm not going to do that. I think I can though. Let me see. Maybe I will. Yeah, I can even switch over to here, and last thing, and then we'll move on, Seth. You can fade and all that fun stuff. So anyway, there's all kinds of cool stuff there. Yeah.
Yeah, you got it all set up. All right. Daniel asks, is there a priority for nodes and services, or do they need to be manually configured?
You can set a priority. Normally, no, there's not a priority. Normally, it's up to the scheduler to, if you say, Daniel, I want, 5 things, whatever those are, we'll say pods, then it will schedule them, and it will schedule them on the pods, because if a pod is, a node, let me back up, there's so many terms. A node can get very busy. So if it detects it's too busy, it might actually schedule that later when it's a little more freed up, because it doesn't want to eat up too much CPU and memory. So, but you can also assign priorities as well. That's possible. That could be done in YAML, and I haven't done that through the command line. You can probably do it on the command line too. I haven't tried that one though.
Awesome. Another question, since pods live and die, how does Kubernetes handle persistent storage? For example, a database running in a pod.
Persistent storage is actually pretty much what it's called. They have something called persistent volumes. And there are in fact, let me just jump real quick here. Yeah, there we go. So if you go to kubernetes.io and go to documentation, if you just search for like volume, for example, this should pull up a bunch of stuff. Yeah, here we go. Persistent volumes is what I want. You will be completely inundated with options. There are volumes you can do with Azure, GCP, AWS. There are just node volumes where it just stores it on the node itself, which is kind of dangerous because a node could crash. So that is actually what it's called, though. It's called a persistent volume. That one I won't have time to go into because it's a very big topic. But just know that you can absolutely tie into pretty much any type of storage that's supported. And there's just a huge list that's available. So good question.
Awesome. So we're getting a lot of questions now, Dan. If you hop in the Q&A or the chat,
yeah, I'm in
and
there
see
now.
anything that strikes out to you, feel free to cut me off.
Okay, yeah. Let me just so Laxmi, hopefully I'm saying your name right. If the pod dies or crashes, then the new pod is created. Yeah, pods are never resurrected. When a pod dies, it's gone. There's no way to bring it back. That's why the IP address can change. So what Kubernetes will do there is if you had 3 pods, you said that your deployment said I want 3, but you're now down to 2, it detects that. All right, that's why you have the kubelet on all the nodes, because the kubelet can say, whoa, a pod died, what do we do? And then the master node can then schedule to get that new pod on there. Now that'll get a new IP, but that's okay because you'll have those services that act as the doorway to get to all the pods. So even if their IP address has changed, like I already covered, no big deal. So yeah, but it'll always be new.
So here's another one. Does the .kubernetes file need to be run in a particular sequence or order, or does that not make a difference?
No, that's the nice thing with that. kubectl apply I ran -f, and I gave it the folder. Now it'll figure all that out for you. Now, I suppose there might be a scenario where you wanted something out there first. In that case, you might do multiple apply commands, but normally no. You can just say run all these files and poof. So when you're in real life, hopefully a human would never run that command in production. It would hopefully be scheduled through like a continuous integration, continuous deployment type CI/CD system. It would be automated. And that way, there's no chance for mess ups there. See, you guys see anything else, Seth, you want to do, or you want me to just grab one?
Here's a good one from Anonymous. Does using Kubernetes to run a pod locally help in terms of debugging? For example, if a pod fails in the pipeline, and you need more additional information on why it failed.
The magic there, that's a good reason as a developer that you should at least know how to run and how to deploy and how to debug. Because if you don't, odds are your IT admin is not a developer, or your DevOps or whatever you call them, your sysadmin, at work. They're probably not a developer. And the more you know about this, you're just going to like totally shine, right? Because, career-wise, because they're going to be like, wow, like you actually know how this works. And to me, that's always the big argument why I would want to learn this as a developer is, yeah, I could just say, all right, my container's ready, my image is ready, and then let other people handle it. But then what happens when things go wrong, which they do? So you can actually do all kinds of stuff. I'll give you an example. In Docker, you could do something like this: Docker exec, name of container, and you could shell into the container. Well, you can do the same thing with Kubernetes, actually. You can execute a command in a pod's container, or I can inspect. So real quick here. I don't want to take too much because we've got a lot of questions, but let me just run this other pod here real fast. We'll get it going again. Okay. And now I can actually come in. And if you do a git pod hello nginx -o like JSON or YAML, I can actually go in and get lots of details about what's going on with this particular pod. So I can find its IP address, volumes it has, and I'll go back up to the command in case anybody cares. That's what I did right there. So bottom line, you can inspect pods and their containers. You can shell into a running container in a pod, and knowing how to do that is great. And since it's free for April, I cover all that type of stuff in the Kubernetes for Developers learning path. So if you're interested, go check that out.
Awesome. This is kind of a higher level question from Jeremy, but I think this might be a good one. And then we can maybe take like 2 more of the technical questions before we wrap up.
Okay. Sure.
But Jeremy asked, for teams who build and operate their applications, would you consider Kubernetes as a potential fit, or is it more of a better fit for teams with centralized IT ops or DevOps?
I guess it could work with either. Here's my big thing with Kubernetes. I started off saying this. I've seen before joining Microsoft, I've been there about 9 months now. I ran a consulting company for about 20 years. I changed because I was like, wow, this staying at home is actually nice. I used to travel a lot and I got really tired of that. So anyway, long story short, a lot of companies, you know how it is. Your CIO or a director level person goes to a conference or an online, I guess these days, they hear somebody like me say, hey, Kubernetes. And then they're like, we need to do Kubernetes. And for a lot of apps, I'm going to argue, especially internal apps, you probably don't need Kubernetes. Now containers, you can argue with me all day on that. I'm a huge fan of containers for everything. But do you need Kubernetes for everything? No. So my first thing I'd say about that question, which doesn't answer it yet, but I will, is Kubernetes is one of those right tool for the right job. It is not the right tool for every job. It's like the Swiss Army knife that'll give you all these bells and whistles, but you're like, all I need was a butter knife for this app. It adds complexity. It's amazing what it does, but it adds complexity. So to answer your question, it can work in either of those scenarios, but you absolutely need a Kubernetes admin. You need somebody who knows Kubernetes inside and out, because as networking issues come up, or persistent storage, somebody mentioned, when those issues come up, and they will, because it's technology, who knows it well enough to dive in and get to the bottom of it? Now, maybe that's you, I don't know. But anyway, that's my answer is it can work in either, but you definitely need somebody who's good at Kubernetes.
Awesome. Yeah, that totally makes sense. So Persona asked, does Kubernetes come with default security?
Well, yes and no. No, if you're talking security, like I want to hook into, I'm using Azure Active Directory or Kerberos or something like that at work for login, you're going to have to do that, right? It will not do that. Now, if you're using some of the cloud providers out there, now I can mainly speak to AKS, which is Azure Kubernetes Service, because that's the one I've used the most. But I'm sure Google does it and AWS does it as well. But if you're using one of those, then yeah, you can get some supporting infrastructure around security. Out of the box, though, when it comes to security, such as a username, password, or pass-through authentication type things, authorization, no. You'll still have to do that as part of your container deployment. However, there are things that can wrap that to simplify it for you. But out of the box, no. Like on Docker Desktop, no, you get 0 of that. So keep that in mind. Good question.
Awesome. So I like this question from Gene as maybe a good wrap up, and I think it goes back to the butter knife analogy you just shared. But they asked if you could talk a little bit about the misuse of Kubernetes, like when should it be used and when should it not be used?
Sure, I'll give you a real life example. So one of my first jobs out of college, about 3 years after, I went to work for a government organization here in Arizona called Maricopa County, and great job. That was the coolest boss I ever had. But anyway, I was young and maybe didn't know better. But in that job, we built mostly internal web apps, and we maybe would have 10 simultaneous users on these apps. So scalability was not an issue. There was some where scalability mattered. Open enrollment, for example, because we had back then around 13,000 employees, and they had 2 weeks to enroll in benefits. Now, most of the apps we did, though, in that org, they just had a web server and they had a database. That's it. Kubernetes needed there? Probably not, right? Now, if you came at me and said, well, Dan, our app is, we're doing microservices, or we just have a lot of moving parts. We have a lot of APIs in the app. We need scalability, elasticity, if you will. Whether you containerize your database or not, you'd have to talk to your DBAs on that one, because some companies do, some companies don't. I love it because it makes it easy to swap out your database versions, but now you need persistent storage for sure. So anyway, an example then would be a line of business app, doesn't have high scalability requirements. The odds of it failing are very low. And it would be just as easy, whether you're using cloud or not, to either use a container service in the cloud, if you're using the cloud, because there's lots of services out there that'll just run containers. Or if you're running it locally, so just monitor the containers. It'd be just as easy. I'll give you another example. So in Scottsdale, which is just not too far from where I live in Arizona, I'm in the Phoenix area. There was a company that had 24 or 5 independent pieces running for a sales app. They wrote custom sales app, because the world doesn't have enough custom sales apps. That's a pretty good use case for Kubernetes, because now when you're not talking one container or 2 containers, you're talking lots of containers. Who's going to manage all those, right? Some of you may say, well, you could use Docker Compose. Yeah, you could, but Docker Compose, if it crashes, there's a little bit of help there, but not much. So, and Docker Compose wasn't intended for production use cases, although people do use it for that sometimes. So that'd be kind of the trade-off. So if you're going like Amazon, I have no idea what Amazon.com does. Perfect use case for Kubernetes. I mean, they need the ultimate scalability, right? Whereas some of you are probably just building line of business apps, not that many users. You probably don't need Kubernetes for that. So bottom line, do your research before you jump in. So sorry, that was a long answer, Seth, but.
No, that was great. Well, Dan, thank you so much for joining us today. I don't know if you have the slide with your Twitter handles again that we could throw up just here at the end. I just want to plug to make sure people go and follow you. I'm not going to volunteer Dan to do this, but I'm sure he's happy to answer any additional questions that you might have if you reach out to him there. He's very active and generous, engaged on Twitter. Again, look for the recording for this webinar in your email within about 1 to 2 days. You can also go onto the Pluralsight Twitter, Facebook, YouTube account, and you'll be able to see a recording right now for it. And just again, another plug to go check out Dan's courses on Pluralsight. They'll be free for the entire month of April, so you really have no excuse to not go look at them right now. And then Dan, do you have any kind of final takeaway on the topic of Kubernetes before we leave?
No, I would say for those that are brand new to this, get good at containers first. So, again, it's free this month. So normally I wouldn't say this because I don't like to totally, self-pump my own stuff, but it's free this month. Go check out, I have a Docker for web developers course. And go check that out, because that'll get you into using containers. Or I even have a brand new one that just came out last week that's a really short version of that. Get a container at containers before you jump to Kubernetes, because once you make that jump to Kubernetes, the assumption is you're already comfortable with containers and images and how that all works. So to wrap up then, once you know containers, and if you feel you have a good use case for Kubernetes, and there are many use cases for it, then go ahead and jump into one of the courses, go to the docs. They actually have decent docs on kubernetes.io. and then, go from there. The last thing I'd say is if your job is also developer/production support, I'd be pretty hesitant to be the Kubernetes admin and have responsibility for development as well. So as I mentioned earlier, you really need if you're going to go Kubernetes, you really do, in my opinion, need a dedicated Kubernetes admin type person. So, and that's it. So thanks a lot, Seth. Thanks everybody for tuning in.
All right. Thank you. Bye.